state that temperature determines the direction of thermal energy transfer between two objects. We have object A and object B, both at 20 degrees. There will be a transfer of thermal energy from A to B, and there will be a transfer of thermal energy from B to A. These will be in opposite directions, and the rate of energy transfer will be the same. When this happens, we get thermal equilibrium when they're at the same temperature. Now, if one is at a higher temperature than the other, we do not have thermal equilibrium. There will be more energy transferred from A to B than there will be from B to A. What will happen is, because they do have a temperature difference, A will cool down and B will heat up. Initially, the thermal energy is transferred from A to B. There's a net transfer of thermal energy. But eventually, they will be in thermal equilibrium. They will both be at around 35 degrees. State the relationship between the Kelvin and Celsius scales of temperature. Here we have 3 scales of temperature. We're most interested in the green one and the blue one. Note that between here and here is a difference of 100. Between here and here is a difference of 100. It's just that they have different starting points. The absolute, or the Kelvin scale, starts at 0. Water freezes at 273 and boils at 373. The centigrade scale, it starts at negative 273. Water freezes at 0 degrees centigrade and boils at 100 degrees centigrade. We don't need to worry about Fahrenheit. To go from centigrade to Kelvin, you need to add 273. 0 plus 273 becomes 273. 100 plus 273 becomes 373. To go from Kelvin to centigrade, we have to subtract 273. So, to get the temperature in Kelvin, we find the temperature in centigrade and add 273. What is 37 degrees in Kelvin? Well, it's going to be 37 plus 273, which will be 310 Kelvin. Now we have to understand is, what is the difference between a hot object and a cool object? It's not just to do with the temperature. Let's say in the room where you are now, you have a table which has metal parts and plastic parts. They will both be at the same temperature because your room will be about 22 degrees. If you feel the metal object, it feels colder than the warm object. Why does that happen? They're both at the same temperature, but one can feel colder than the other. And it's basically because you are warmer than the table, and when you touch the metal conducts and it takes the heat away from you, and therefore your skin will cool, and therefore it will feel colder. Whereas plastic doesn't conduct so well, and it will not take the heat away from you so much. On a nice Scandinavian summer's day, the temperature is 20 degrees, and let's say you have a pool which is heated to 20 degrees. However, the pool will feel much colder than the air. They're at the same temperature, but the pool will take the heat away from your body at a much faster rate, and the skin will cool quicker.